Firstly, I would like to welcome first speaker of today. He's the CTO at Spotin, Michel. So Michel, if you want to go ahead and turn on your camera and mute yourself, I will give you the virtual floor.
Thank you.
And take it away.
Thank you so much for the nice intro, and thanks for having me here. I'm quite excited to be in this event and look forward to hear other speakers as well. Okay, today I'm going to talk about the opportunities and challenges of utilizing latest AI trends in the software development lifecycle. So I will try to touch base the very basics and not go into too much details as we have a very limited time. So I am currently CTO at Spotin and basically leading the technical vision and strategy of Spotin's product. And besides, I'm also a PhD candidate in computer science doing research in the field of performance optimization of cloud native systems. And about to defend very soon in a few months. And also, besides, I had over 50 years of experience in the software industry as solution architect, tech lead, and full stack developer. The topics that I'm going to touch base includes a very brief introduction to the latest AI trends within different disciplines of AI, and then talk about the scalable use of AI in SDL and potential example and challenges of using AI in our pipelines. So let's start by very briefly explain the latest trends and different disciplines of AI. Of course, AI is a very wide and broad topic and includes many subdisciplines. By its own, it is based, many parts of it, especially machine learning, is based on statistical analysis. But I'm not going to talk about that part. I will try to focus on the artificial intelligence itself. So one of the most important subdisciplines of AI is called machine learning, which is basically a discipline that enables machines to learn from data and improve their performance on a specific task without being explicitly programmed to do it. So it basically learns from the historical data and a lot of data. And one of the subdisciplines of machine learning is called deep learning, which is basically necessarily involves neural networks that have multiple layers and work with very complex data. And particularly effective, these set of rules and techniques are particularly effective to work with very complex patterns and a lot of that also have a lot of data available to learn from. I will explain more about it later. One of the probably oldest disciplines of AI and recently try to take advantage of machine learning techniques are called expert systems, which mimic the decision-making abilities of human experts and use rules and knowledge bases to provide advice and insights. And it's as I said, it's one of the oldest ones. And if you look at the history, the history goes back to 60 years. And if you look at the available information about expert system, many companies at that time started with the hype, but then over time it fell apart. And one of the bottlenecks was infrastructure. And now that the infrastructure is being fixed, it seems like there are evidence that it's rising again. One of the good things about it is that it's very, very nice for problems that the boundaries are well defined, and you basically can write the system as a bunch of if-elses. The advantage of it over, for example, neural networks is that neural networks are treated as a black box, but with the expert systems, you can debug the system. But then there are evidence that you can use existing tools in AI to create debuggable expert systems in the future. And one of the very well-known companies active in this field are Psycorp, which is founded by Douglas Lennart, one of the prominent researchers in AI and machine learning. And yeah, they have a quite interesting tool. Has 50 million, if I'm not, no, 30 million parameters. Yeah, specifically designed for logic-based machine reasoning. Take a look at what they do. Another subdiscipline of AI is computer vision, which basically focuses on developing algorithm and systems that can enable machines to interpret and understand visual data from the world around them. And yeah, convolutional neural networks and generative adversarial networks are two of the hot topics in this area. And one of the latest trends are, maybe you heard about it, are deepfakes. That, of course, there are many, it's pretty controversial, but also it can be used in, for example, film industry to you can replace actors by their deepfake version. There is a lot of activities happening there. Of course, not all of us have in film industry. So, but there, I already started to see many startups started to use deepfake techniques to automate, for example, tutorial generation. An example, in your pipeline, you create new features, and you already take time from one of your nice-looking colleagues to create a interesting tutorial for those features, but then you change that feature, and then that tutorial kind of gets obsolete. So with deepfakes, you can kind of mimic that tutorial or recreate that tutorial based on the description that is provided. And there are a few interesting startups just focusing on automating tutorial generation and video tutorial generations. DALL-E, another very hot topic and trend, which basically it's mostly used for fun and most artists, for example, but also there are startups that started to use that technique and techniques behind DALL-E to create product mocks. For example, in e-commerce, you can generate unlimited number of product images, basically, theoretically. Of course, it's not like that in reality, but your customers can see products in different settings, and that's quite interesting. In robotics, there are quite a lot of advancements in object detection, and I can say you should expect a lot of interesting things happening in the robotics. And another hot topic is video understanding. Especially, this is very important in pipelines related to finance and computational investment, where in your pipelines, when you want to analyze latest news, you don't have to hire people to do that. You can have basically a tool that understands, here's the latest news, understand this, and then you can feed that information into your decision-making pipelines. One of the other very controversial topics or natural subdisciplines of AI are natural language processing, which basically enables machines to interpret human language, both written and spoken. And one of the most important advancements in this area is transformers, which first introduced in 2017 by a very famous paper, Attention is All You Need. And basically, it designed basically to process sequences of data, such as the data that we have in our natural language sentences, and very suitable for do language translations, text summarizations, and also language modeling. And you already know one of the algorithms that are based on it, which is GPT algorithm, as well as BERT. One of the very interesting things that you can use in your pipeline are pre-trained language models based on GPT. For example, OpenAI's API, which you basically can take that pre-trained model, you can feed in your own data, and you can train a model based on your data. So that model basically learns from the knowledge that you provided to it without a lot of training or a lot of costs. So these pre-trained language models are pretty useful for things like sentiment analysis, for example, analyzing comments in social media and understanding the behavior of your users, and also support ticket automations. One of the biggest challenges of big companies is to how they can support their customers in a more efficient way. And I'm sure you stumbled upon websites that already have a robot for support ticket, uh, for answering support tickets. Also, you can create your own automated chatbots with very little effort. Basically, you feed in your data, your employment, your company's data, and then your employees internally can ask questions like how many off days you can take, things like that. And then that chatbot can answer. Externally, also your customers can ask questions about your business or about your product or whatever. That's quite amazing. That you can do with very little effort nowadays. And so on. There are other topics that related to the machine learning, logistic regression, decision trees, evolutionary component reinforcement learning, that each of them, of course, requires its own session to talk about. But then if to simplify this model into just artificial intelligence, machine learning, and deep learning, we have from the other side have data science. So all these models require data to work, and the good data. And of course, data science itself is based on statistical analysis. As a day-to-day data scientist, you have to create the predict models. You have to do text mining. You have to do clustering and segmentations. You do a lot of data visualization in your day-to-day work. And also, you need to know a little bit of the business and soft skills to communicate with different parties in your company to understand what's the best model to use, or what is the best approach to create the models or to train your models. But then if you think about it, this is all good. Like, you can hire a data scientist from one side and you can hire a data engineer from the other side. You can create prototypes that work and you can train models that are useful. That's fine. But then the question is, how can we scale? How can we use them in scale? And that's a very, very challenging thing. And that's where DevOps comes in. And then if a new concept that basically connects all these three together are called machine learning ops, or ML ops, which basically involves of automating and combining DevOps with data and ML pipelines. And I'll explain in a bit. So how can we go towards the scalable use of AI in SDL? So a traditional software development lifecycle includes that you have a bunch of sprint goals. Let's put it this way. Let's say you are using Scrum, and then you want to get a bunch of implemented features. So of course you have a development team that does the development, and of course you have an operations team that does the operations. Development team, of course, is based on agile culture, and they are working in the framework of, for example, Scrum or Lean framework. And then you have a pretty good quality assurance structure. You then have an infrastructure that your code is running upon, and you have defining your standards. And then this is a typical DevOps process that you do planning, you create your application, you do quality assurance and verify it, you package it, and then you have an automated pipeline for release. You have automated pipeline that does all the configurations based on latest version, and then you have proper monitoring tools. Awesome, perfect. And then you have your own continuous integration and continuous deployment. But if you look at this is a typical software development lifecycle. If you want to have, but then your data scientist team have a different pipeline. They have their own objectives, and they want to get insights or decisions based on those objectives and requirements. So you, from one side, you have data, and you follow they follow the best practices and in an iterative way. And then in AI ML side, they of course have to choose what are the right tools, and of course they have to take care of the privacy. So they do the data collection, they create the data, which basically involves cleaning, transforming, feature engineering, data splitting, etc. They transform the data in a way that they do the feature scaling, for example, to make sure that the data is in the correct scale, also to improve the performance. they reduce the dimension of the data that they collected, they normalize the data, they transform the unstructured data into a structured data so that it can be fed into the machine learning, etc. So they have to automate that in order to go to scale. So they have their own pipelines. And then to validate the collected data. And then in the machine learning part, you do the training, you do the evaluation, and then you do formulate the problem, and then you keep doing this if new data comes in. And but then if you want to combine these two together, you have to create a new pipeline, and that's all about the ML ops, which you basically connect all these together in a way that you formulate, you then go to the data part, and then you train your models, and then you, in your dev side, you do the development, and then you go to the operations side. To give you a quick example, very quickly, let's say we have a developer that, and then we have a data scientist. The developer, of course, does the coding, and the data scientist does its job in the Jupyter and works with OpenAI. And then after it finishes its job, it stores the fine-tuned models into, let's say, Google BigQuery and Weights and Biases, for example. They are popular tools for data scientists. The developer, of course, after it finishes the code, pushes the code to the GitLab, and that's where the pipeline starts to run. And then it fetches the fetches the models from these Google BigQuery and Weights and Biases, and that's the part that ML Ops. If you have ML Ops, you can combine these into a nice package and then build it in, and for example, GCP Container Registry, and then you can release your application, and then the deploy is done. That's a typical and simple pipeline. There are a few challenges though, like staff training, team collaboration, and cultural shift, where of course, ML Ops requires specialized skills and knowledge that may not be readily available within an organization, especially if you haven't done it before. The team collaboration is another problem that, of course, the team have to collaborate, and of course, the culture should understand about the concepts. The privacy and security is an important thing that you have to consider in your ML Ops, where you should not you should make sure that you don't have sensitive information in your model, and also your model should be secure itself, so that, for example, it's secure over model poisoning attacks, etc., or the infrastructure is secure itself, so no one can also copy your model. So there are many articles around that, and you should have a testing and validation, and also you have to have a well-performing model. It's easy to create models, but it's hard to create models that perform efficiently on a scale. And then, of course, you have to take care of the cost. And that's all for me today. Thanks for listening.